Welcome, everyone. Today's panel is sponsored by CALMA, the Center for Advances in Libraries, Museums, and Archives at the University of Washington Information School. If you're new to CALMA, I'd invite you to check out our website, which is there on the slide, to learn more and sign up for our listserv to receive occasional updates on our programming and the LAM research that's happening here at the Information School and with our affiliates. Next slide, please. I also just wanted to kick this off with a land acknowledgement. The University of Washington acknowledges the Coast Salish peoples of this land, the land which touches the shared waters of all tribes and bands within the Suquamish, Tulalip, and Muckleshoot nations. If you're not in the Seattle area, which I think goes for most of the people here, I encourage you to go to nativeland.ca to learn more about the people indigenous to where you live. Next slide. Today's panel is entitled Artificial Intelligence and Machine Learning and Metadata, Possibilities, Limitations, and Ethical Implications. I will now hand it over to today's moderator, Crystal Iragi.
Hello, everyone. Thank you for coming, and I want to thank all of our panelists for being here. This is going to be a fun event. So our plan for the next hour and a half is to introduce our speakers for a couple of minutes. And then each panelist will give a brief presentation about how their work intersects with machine learning and artificial intelligence. And then we've got some planned questions for our panelists that I will ask. And the last 15 minutes will open up for Q&A from attendees. Attendees, if you're able to use the chat to put in your questions, that might be the easiest way to do that Q&A since there are so many of you. Today's speakers are really excellent. We've got Morag Boyd from OCLC, and Morag will do a presentation on her work soon. And then we've got Charlene Chow, who works at the New York University Libraries as the head of their metadata department there. We've got Jeremy Nelson, who works at Stanford. Jeremy is one of the masterminds behind the Sinopia linked data editor and does a lot of really great metadata stuff there. And then we've got Philippe Sade. Sorry if I pronounced your name wrong. Philippe works at the Wikimedia Foundation as a software person and knows a lot about how Wikimedia and AI intersect. So does Denny Randachik. Is that how you say it? I'm sorry. I should have checked in on last names before I started this presentation. But Denny is one of the folks who I believe made Abstract Wikimedia, one of the founders of Wikidata, a very knowledgeable person about AI and the Wikimedia landscape as well. And then we have Ozma Suominen. I wrecked it. I'm sorry. You can all mispronounce my last name too. Ozma works at the National Library of Finland and is one of the folks behind ANIF, the automated subject indexing software that has gotten a lot of positive press over the years. So with that, I'll turn it over to Morag for your presentation.
Hello, everybody. I'm happy to be here speaking with you about this topic today. My position at OCLC is Director of Metadata Applications and Engagement. So what that means is I work with the product teams who are really trying to define, the features and functionality of the applications that people use to interact with OCLC metadata. And more specifically, kind of in the cataloging, and electronic collections areas. So it's very interesting because we have to sort of anticipate what we think is going to be important to libraries and think about building those things before perhaps somebody's asking us specifically for them. So AI has been like really and I've been with OCLC about a year, and I did come from an academic library, and kind of the outlook on AI really struck me within my first few days as being very different from coming from a sort of AI cautious environment, one where they're like literally telling us, use AI to write your annual self-appraisal. I'm like, that is not what they would have told me on my last job last week, right? So but then thinking about the power of AI to really unlock the capabilities, the knowledge, and the metadata within libraries to highlight our collections and, most importantly, connect people with information, which is fundamentally what I believe is the core of metadata work and library work. And OCLC has really kind of taken a very thoughtful and values-based approach to thinking about how to integrate AI both into our internal work and into those products and services that we are delivering for libraries. And the core of that is that AI should be amplifying human expertise and not replacing it. And we should be really sustainable and thoughtful in how we think about utilizing AI. And we're specifically thinking about it in the frame of library use and enhancing library services. Next slide, please. So I'm just going to talk through a few ways that we've kind of specifically applied some AI methodologies towards specifically some metadata applications. So one of the biggest ones has been using machine learning to deal with duplication. About 2/3 of the data that shows up at OCLC every day is duplicate. So duplication and deduplication is a huge part of our work. And there's a great opportunity with machine learning to remove duplicates. So we have identified approximately 50, actually we're closer to 16 million now. Duplicates have been removed from the approximately 650 million bibliographic records that are in WorldCat. There is a process where libraries can let us know if we inappropriately merged, and we've got about 300 of those reports. So feels like it's been pretty successful. The machine learning was partially trained and informed by volunteers from the library community who did pairwise matching to let us know if we were correctly identifying duplicates, and we were able to sort of modify the model to more accurately deal with duplicates. Next slide. Another feature that we have put out is really looking at AI for metadata enrichment, which lets the user opt in to the tool, and then they can click a button and be offered suggestions for Dewey Decimal classification, Library of Congress classification, or Library of Congress subject headings. What is most critical about this, and if you can just go to the next slide, Crystal, many times when I talk to libraries, they assume that we're using generative AI, and this is not a generative AI application. This is really a vector search. So it's kind of like the algorithm turns concepts into numbers and uses those to do match points between the record that somebody wants to enhance to data that is in WorldCat. So the only thing it is matching you towards is already in WorldCat. So the usual caveats apply, right? Just because in WorldCat, a person might have put it in, and you know what? People make mistakes too. So sometimes there are errors in kind of what it's matching to, or errors in the sense like it could be outdated, maybe an outdated classification or something like that. So this has been interesting to also see how libraries respond to thinking about something that does help in an area of description that takes the most time, but also requires the most expertise. So we can kind of delve into some of those conundrums later. Next slide. And then the last one I wanted to mention was just we have just recently issued there's a new service that uses AI to do alt text generation for image files in Content DM. This is a closed model, so again, it's not like it's not using a public LLM, and it generates alt text for these images, drawing heavily on the metadata that has already been supplied for the images in the resource in Content DM. So it's very interesting, but a key thing about it as well is the AI-assisted coding let us basically take it from a non-technical person, prototyped it using some AI-assisted tools when we felt like it was going to be useful service, moved it through our more formal development process. But through it, we basically took it from idea to production ready in 6 weeks, which is considerably faster than previous models. And so really thinking about how we can use AI to take the best advantage of our internal human expertise and capacity to more quickly deliver to libraries is also an interesting aspect of how we are integrating AI into OCLC. So with that, I'll hand it over to the next presenter.
Thank you, Morag. Now we have a presentation from Charlene.
Yes, I would like to share NYU use cases. Since December 2023, our metadata librarian have already tested, different AI tools for metadata generation and remediation. So it's more than 2 years. So we have present and published our findings, maybe at some conferences, meetings, and even in journals. But today, I would like to focus my report on interdisciplinary research project that align with NYU strategic pathway and directions. So my team has been collaborated with university IT and faculty to explore the potential for this interdisciplinary projects. So for example, we really believe we would like to participate proactively in ethical AI project and creating quality data sets and metadata. So, LLM is really trying to support AGI is artificial general intelligence. However, for university or academic library, we believe we would like to create really specialized data sets for scholars. So we've been doing this kind of project. We believe the partnership, including metadata librarian, domain experts, such as faculty or scholars and data scientists, especially those with expertise in machine learning and natural language processing. On the other hand, we also discover a lot of changes in the open. It's really for the scholarly communication community, either for open access or open scholarship. How can we redefine and optimize discovery with the global context? Next slide, please. So I remember I sponsored a capstone project at University of Washington High School in 2021. And that's really a great experience for me to inspire me with natural language processing with machine learning. And so I would like to share the use case number one is, and because of that positive experience, I sponsor another capstone project at NYU School of Engineering. And this one is I really encourage my students that evaluating library catalog, research guide, and institutional repository, and try to describe their experience, special user experience. And they are very frustrated. I have a lot of concern. And then I say, okay, now we're going to migrate our faculty digital archive to the new platform next year. So I really wanted to see, can they really design a semantic search engine? And this poster proof the concept is amazing how they use OCR, embedding, vector store. And so all of this is amazing interface. We are able to search using the natural language and also with that confidence score, with that similarity score. So my students really learn a lot. It's quite amazing. They didn't know anything about library metadata before this project, but after 2 months, and they say, oh my God, it's so important for OCR and metadata to support discovery. Next slide, please. Yes, this is use case number 2. So last year, I submit a research proposal to the Center for Data Science. And that means I do have a case. I really want data science student to work with me. I still remember when I interviewed one student, and he challenged me, say, why library catalog still keyword based? Can we have a semantic search platform? And can we really improve and really, improve the technology or discovery? So this is an example. After 1 year, it's quite amazing. So we use this case, is called Open Square. It's really a open access ebooks published by NYU Press. So we don't have to deal with any copyright concern. And I got a green light from the press. And so for this case, again, the website itself is keyword search. And so my student really want to load all the, the metadata, and also with part of the full text. And you can see the pipeline on my left-hand side, how to really embedding vector store and become the embedding generation and for that semantic search. And also the right-hand side with that search box, so that user can search in the natural language or plain English and not really just keyword-based. Next slide. So I would like to conclude my report in a few key takeaways. We truly believe, in the research data ecosystem or open data community. So we really see some like an emerging trend. AI data governance is evolving through the new standards such as Croissant for machine learning metadata. And also, I think the future of knowledge organization lies in the convergence of subject disciplines and compute data science. So we also truly believe in we need to apply responsible AI principle, which is also as one of the key initiatives at NYU Center for Responsible AI. So all our testing or pilot project, we keep human in the loop for the best result. I also strongly recommend we need to assess and test AI tools thoroughly before using them in your department or daily work. That's all.
Thank you, Charlene. That was a great presentation. Let's scooch to Jeremy.
Hi, everyone. My name is Jeremy Nelson. I'm a software developer at Stanford University Libraries. And I'm going to talk about two areas where at Stanford, we've been looking at applying AI, and in particular generative AI, to metadata workflows. And I'm going to be talking about context engineering, which is sort of the idea that your model, your generative AI model, has a limit of how much it can sort of load into its working memory. And to be able to really leverage and optimize the use of that large language model, there are various techniques that you can do to sort of improve what that context is sent to the model. And in particular, in metadata work, we have a couple of different techniques to really sort of optimize that context window related to this context engineering. So I'm going to talk about in two areas that we've been applying this idea of context engineering. The first I want to talk about is BlueCore. So BlueCore is a multi-institutional shared BibFrame RDF data store. Other partners besides Stanford include Cornell University, Library of Congress, University of California, Davis, and University of Pennsylvania. And in the past, in 2025, we did a full year prototype. And as part of that prototype, we enabled a number of different services. And one of those services was a API. And the API supported the Sinopia linked data editor as well as the Marva linked editor. So it gave catalogers and other metadata staff opportunity to use sort of the editor of their choice. Now, when we were starting the development and the architecture of BlueCore, I really sort of emphasized being able to support AI. And one of the key ways we're doing that is that the API is also a model context protocol or MC service. Now, what MCP is, it's a sort of a standard of how these large language models can communicate with external systems. And it gives the model opportunities to be able to use some of the API endpoints or some of the functionality that your API or your system provides. And so in BlueCore, you can actually use the MCP, the API, to do various workflows and be able to hook up different types of models. So for example, you can use Claude Code or Claude Desktop. You can also use ChatGPT. So there's various ways that you can sort of hook up into and use Blue Core into your system. And you may have multiple MCP services. And some other work. So Stanford is a Folio library. And I've been working with the Folio community. The past few years, I've given an AI workshop, pre-conference workshop. And as part of that work, we've developed a Edge AI module that is also an MCP service. And it exposes a limited set of Folio APIs, but it also adds in an agentic AI, which I'm going to talk about in the next slide. But that's also an MCP server. Another activity sort of under this umbrella of context engineering is something called RAG, or retrieval augmented generation. And in Blue Core, we've been doing some experiments with using the triples that are generated from all the works and instances and storing each of the triple in a RAG system to support some functionality, which I'll talk about in the next slide. We've also, on my team at Stanford, we've looked at using the Folio inventory RAG, sort of generating short little descriptions of the inventory records, and that sort of opens up some discovery opportunities. And the final thing I'll say is that in the Stanford libraries, we've started sort of supported and driven by our Tom Kramer, associate university librarian, on seeing how we can use RAG just across the different library systems, and how do we support the different uses that people may have. Next slide. Oh, so the other sort of aspect I want to talk about is our AI agents. And so context engineering can really support AI agents. And in the two sort of contexts for metadata, in Blue Core, we've created a simple deduplication AI agent for identifying duplicates for BibFrame works and instances that may come in. We've also done a little bit of experimentation, but I hope to be able to continue that as we're developing the MVP, or the minimal viable product for in this year, to sort of enable a Sparkle-like search query that's not actually using a triple store, but using Postgres as the data store behind the scenes. Other places where we're using AI agents is in the Folio Edge AI module I mentioned. And we do have an inventory agent. And we created a little front-end app at Stanford. And it allows catalogers or metadata staff to generate inventory records from a text prompt. And it also allows users to upload a book cover image. And it'll also, from that just book cover image, the inventory agent can take that and generate a stub record as well by extracting title information and author or contributor information from that. We've also, as part of that, did some experimental invoice ingestion. So in our acquisitions groups, when an invoice comes in, we can use this inventory agent to extract and create an invoice. And we're looking at sort of expanding that from order records, generating stub inventory records as well. So those are two areas more broadly, using AI agents and context engineering, in particular to support metadata workflows at Stanford.
Hello. Yeah, so I'm part of the Wikimedia Deutschland team. And mostly at Wikimedia Deutschland, we focus on Wikidata. So I thought I'd share like a very, very brief introduction to Wikidata. And then I'll share the AI work that we've been doing with Wikidata. So Wikidata is a free and open knowledge graph, one of the largest Wikimedia projects. What's very particular about Wikidata is how it stores its information. And it stores them in a structured, connected statements. So it has a list of entities, for example, Douglas Adams. And when you open the entity for Douglas Adams, you can see a list of statements One of them being, for example, Cambridge, how it connects Douglas Adams to Cambridge, and it connects it with a particular property. In this case, it would be residence. Next slide. What makes this particularly special in Wikidata, the way it's structured, it allows you to do complex queries with the data. So let's say you want to find all books written by Douglas Adams that are published in a certain period. You can do so by writing a Sparkle query and executing it on Wikidata. And then you can execute the Sparkle query and get a list of table of all the books that are written by Douglas Adams. So the Sparkle query allows you to filter information, go through the statements and the connections in the graph, and aggregate and so on. Now, the problem with Sparkle is that you need to have the technical expertise to be able to use it and to access Wikidata. But not only that, you also need to know in a particular domain how items are connected on Wikidata and also the IDs of the pages or the entities to then write a proper Sparkle query. Next slide. So that's where AI comes in. And with AI, we developed a vector database for Wikidata. And the vector database improves accessibility of Wikidata with semantic search, and it supports the open source AI community to build projects with Wikidata. So similar to the previous presentations that uses the vector database, there's a lot of use cases, like finding duplicates, classification, visualization, and so on. But currently, what made vector databases very popular is RAG, retrieval augmented generation. So with the vector database, a large language model can query with natural language and find relevant information on Wikidata that might help find the answer or narrow down the search. And once this is done, you can then provide context to the large language model from Wikidata to then reference the information and make use out of it. Next slide. Also, on top of the vector database, we also developed an MCP for Wikidata. So as mentioned earlier, MCP is basically providing the large language models with a list of tools with their descriptions and allowing them to execute these tools and get information or whatever the tools are designed to do. So in our case, there's one tool that provides the LLM access to the vector database for discovery, for exploring the content of Wikidata. There's another tool for access directly to Wikidata for graph traversal, for passing through the statements and getting more information. And then there's another tool for Sparkle, for executing Sparkle, basically for more complex queries. And that is all. Thank you.
Thank you so much. That was very interesting. Now we've got a presentation from Osmo.
Hi, everyone. Yeah, so I'm Osmo Suominen from the National Library of Finland. And as a national library, we do quite a lot of things. But in my brief presentation, I will be talking about the in-house do-it-yourself open source solutions we do on the one hand for automated subject indexing and classification, and then a newer thing is the metadata extraction and automated cataloging development. So next slide, please. So starting with the automated subject indexing, our main tools are Annif, that was already mentioned, and the Finto AI service that's built on it. And they try to solve the problem of how can I annotate documents or data with concepts from our controlled vocabularies that we published in Finto. So subject metadata, basically. Next slide, please. So we started developing UNIF already almost 10 years ago, in 2017, and it started as a small project, but it has since grown into something more important. It's an open source tool, or maybe a toolkit for, well, already mentioned automated subject indexing. It's multilingual, supports many vocabularies. It's open source. The code is on GitHub, but we also have a website where you can test it. And there's quite a global development and user community with a user forum, and it's used quite widely, for example, in the national libraries of Germany, Sweden, and Poland, at least, and many other institutions. And yeah, but it's, as you can probably figure out, it's not based on large language models, because those were not around when this started. So it's mostly more traditional machine learning and language technology. Though in recent times we have started integrating also LLM-like things into that. But my personal opinion is that large language models are pretty bad at subject indexing. So if you're trying to use, let's say, ChatGPT to assign LCSH subjects, you're probably doing it wrong. But okay. UNIF is the toolkit, but we have developed a service called Finto AI around it, mostly for the Finnish audience. So librarians, subject librarians working in various Finnish libraries and also museums and archives in some cases are using this to help with their subject indexing. So that's kind of, we have set up it with models and a web form and other things, so that to help them do the subject indexing. So it's mainly for a domestic audience. Okay, next slide, please. So UNIF is something we have done a long time, but this is more recent that we have been starting work with metadata extraction and automated descriptive cataloging. So there the idea is to get basic metadata out of publications, for example, to make a catalog record or some other type of metadata description. And we're mainly using small language models and also have started developing a tool called Bibra. Next slide, please. So here the basic idea is simply to have as a starting point some kind of a document. We have mostly been working with Born Digital PDF files for so far, but it could be also, for example, a photo taken from a title page of a book, or a scanned document of some kind. So it doesn't have to be a PDF. So something to feed into a system, and then we get out a structured metadata that could be like an ad hoc format like this, or it could be a catalog record in, let's say, MARC or BibFrame. Next slide, please. Can you press a few more times to get the bullets out? Yeah, thanks. Sorry, yeah, this one, thanks. Yeah, so it's our solution for this is now consists of three parts. On the one hand, we have built a data set called FinGreylit, which, as you can probably guess, is mainly about Finnish Grey literature. So publicly available PDF files with curated metadata. The documents are in 4 different languages, and we have put this up on GitHub. This is mainly so we can use it both for training and evaluation of different methods. And the second part is the Greylit LM series of fine-tuned small language models. So we start with a general purpose model like Mistral or Gemma, and then we fine-tune it with the most of these FinGreylit documents, so that we can kind of specialize this model into this metadata extraction task. And the third part is the Bibra tool, which is sort of a wrapper around this that provides, can work as a backend service and as a web interface and also a command line interface. Very similar in spirit to UNIF. So it's a toolkit for this task that abstracts the different methods into one interface, and also provides facilities for evaluation. Next slide, please. So here is a screenshot of the current version of Bibra. It's basically a form where you can punch in a PDF and press a button, and then you get metadata out. For now, this is only a very rough prototype of what it is going to be. So we have only just started developing this interface layer. The models themselves, the methods we have been working on for a longer time, but this is kind of wrapping it up into a single interface that can also be demonstrated, and that we can then work with our metadata experts, give them access and get feedback and so on. Okay, next slide, please. So our takeaways or our sort of focus points here. First of all, as is probably obvious from this, is that we try to have the expertise to do these kind of things, to develop things in-house and to build open source things, open data also. And it's kind of a strategic decision not to sort of outsource this, buy it from somewhere else, but try to keep it in our own hands. And also to nurture a community around the tools and the practices around those tools. So that's what we have been doing for a long time with Annif, and what we would also like to do with Bibra. To have others try it out, and if they like it, they can participate in the development. We also want to avoid depending on proprietary or cloud solutions. So all the models we use in Annif and also the small language models we have been using with Bibra they can be really powerful if they are applied in the right way, and we can host them on local infrastructure. We don't have to depend on other people's computers. We also have a strong focus on evaluation, which also means that we have to build our own data sets of well-curated metadata to benchmark against and to use for training. And of course, we want to keep humans in the loop and involve the metadata experts in development of these tools and workflows around those tools. So not to replace them, but to help them do their jobs. Yeah, thank you.
Thank you so much, Asma. All right, last but not least, we have got Denny.
Thank you so much. Those were quite a few interesting presentations already. I want to quickly introduce the idea of abstract Wikipedia, which we are working on. Please, next slide. So the Wikimedia Foundation's goal and the Wikimedia movement's goal is a world where everyone can share in the sum of all knowledge. Now, this is a two-directional thing. To share in the sum of all knowledge doesn't only mean that you can access all the knowledge in the world, but it also means that you are able to share your own knowledge, to bring your own knowledge to the sum of all knowledge. And this is something where one may argue that currently for LLMs, for example, you don't have really a way to tell an LLM, oh, wait, well, something you seem to believe is wrong, or I want to fix it, I want to correct it. LLMs are trained on huge data sets, and including Wikipedia, and we are trying to continue pursuing the goal of a place where anyone can come to and actually fix things, improve the knowledge that we have, work on it together in a commons of knowledge. Next slide, please. So today, Wikipedia has more than 340 languages, provides more than 60 million articles in it on almost 30 million topics. So you could say we seem to be doing pretty good on the goal of giving everyone access to all knowledge, but that's not really the case. Next slide. The assumption that Wikipedia is a single wiki is really not right. It's actually a huge number of individual wikis. So, and the knowledge in those wikis is very unevenly distributed. So we have all these number of wikis. Next slide, please. Next slide. And for example, in English, we have more than 7 million articles, whereas in Turkmen, an official language of Turkmenistan, we have only 7,000 articles. So you see that the language is not exactly the same, and you have very different access to different if you come from a different language background. Next slide. The way we are trying to tackle this is by building on a new project that we launched recently, which is called WikiFunctions. It's the newest of the Wikimedia sister projects. Next slide. What we have in wiki functions is that you basically have a wiki full of functions, a library of functions that can do things. And for example, here we have a function that would calculate the date of the Gregorian Easter. And if you enter the year 2026, the current year, it will tell you April 5th, the results and so on. Now, all of these functions and wiki functions are also created by the community, just like everything in Wikimedia. They are provided by the community. You can call them, you can use them. There are many, many different functions. Next slide. In fact, we have about 4,200 functions available right now, with labels, names, next slide, in more than 100 languages already. So you can use them from a multiplicity of languages. Next slide. And with contributors from more than 50 countries. Here are a few further examples of such functions. Next slide. This is the function so Igbo is a language spoken in Western Africa. And what it does here, it does the imperative form of a verb. So you enter a verb like go, which I think that means read, if I remember correctly. You run it and it tells you, okay, the imperative of that verb form is go. I don't speak any Igbo, so I'm probably pronouncing it terribly wrong. Now, the nice thing here is that it is not only the first time that we have Igbo natural language generation functions available, but also that they are made easily available through the web. Anyone can come in, the Igbo community in particular, can create those functions and make them available to the other Igbo speakers, something which was very difficult before. How would you even set up such a library? How would people easily use it? All of these questions go away through wiki functions, because you can just create those functions in wiki functions and make them available to the world, and they can then use those functions. Now, the natural language generation functions are particularly interesting because we're using those to generate larger sentences. Next slide, for example, here's another function for morphology. For example, it just gets you the plural of a Dutch noun, and it does it also with irregular nouns by looking them up in Wikidata, where we have a lot of lexicographical knowledge. This is what Wikidata is what Philippe earlier explained. Next slide. So what we have in the end is functions that can create whole sentences and then whole paragraphs and whole articles. And currently, for example, we can put in here, for example, is defining role sentence, which creates sentences of the form subject is the whatever of something. And here we have the example of saying, for example, using Amsterdam as the subject, the role being the capital city, and the dependence in Netherlands. The sentence that comes out is Amsterdam is the capital of Netherlands, also displaying that we're not perfect yet. Here's still a few mistakes. This is a thing in the functions that needs to be improved. It should be the Netherlands here, which we currently don't capture appropriately with the functions. The nice thing is we can easily, be as equally be wrong in different languages. So we can switch out the language, for example, from English to Dutch, I think. Next slide, please. And we see then we get a sentence like, oh, that's actually German. One back, please. Amsterdam is the Hauptstadt. No, one further, the one in between. Yes, that one, thank you. Amsterdam is the Hauptstadt von Niederlande. Here also we see a missing article, for example. And this is something that we still need to work on in the functions to improve it. Next slide. So for example, if we want to talk about Seattle, Seattle is a city. Next slide. We can pull this information actually from Wikidata. We have an item in Wikidata for Seattle. We have one for city, and they are actually connected in Wikidata saying, well, Seattle is an instance of city. Now, next slide, wiki functions comes into play, and we can take these slots that we have created, this information, this knowledge in the Wikidata knowledge graph, and actually use those functions that we just have written to create sentences. Next slide. And then we can do this in different languages. So the top one is, for example, is Serbian, where we also see that Seattle is written differently. Then we have French, then we have German. So all of these things generate those sentences in the different languages. And all of these things, all of these are functions created by the community, completely deterministic and controllable. This means if anything is wrong here, like for example, the previous example of the capital of Netherlands, the community can actually go in and fix it and approve it. And the next time you use it, it will be corrected. Next slide. So the infrastructure basically is we have the information in Wikidata about the items, like what index themes, like what is industry, what are the different forms of industry. We can create a sentence in Wiki functions using the functions that we have. For example, the instance was what we just saw with the capital. And then in abstract Wikipedia, we collect those function calls, put them into the right order, and then we create sentences. Like, for example, logging was the first major industry of Seattle. A sentence which is a bit too complex to be actually captured in Wikidata. This is a kind of information which Wikidata isn't particularly good at capturing. So here then the goal is that we can write whole articles like these in abstract Wikipedia and then provide them to the different language editions of Wikipedia in order to create with a high fidelity articles. And the interesting thing is that, that in no way, in no place here, we have actually the vagaries and randomness of LLMs happening. So what we, all of this is controlled, all of these can be edited by the community, and we don't have to guess whether the information is, but actually we still have to guess because it's coming from a community, right? So it's the same problem like with Wikipedia. Humans are actually editing this and can also edit wrong thing information into it, but you can go in and fix it, unlike with the LLM models. And you might now argue, why are we not just using LLMs to translate in different languages, for example? But the thing is that in many of those languages, we actually don't have good models. So as we said, Wikipedia supports more than 300 languages. And for most of those, the translations will actually fail. For the top 50 languages, the translations are pretty good, even though we get there a lot of mistakes, which I wouldn't find acceptable for an encyclopedia. But for the 100, 200 smaller languages, the systems are still currently failing. And one could even argue actually that abstract Wikipedia, should it succeed, will bring a future where we have enough material in those different languages available actually faster and allow for LLMs to also be trained on those languages. Nevertheless, abstract Wikipedia remains a place which is entirely feasible and controlled by the community and builds kind of a complementary counter idea to the way LLMs are used. We are using LLMs in many places, also inside of abstract Wikipedia, but not in the place where it really matters. We are not using it as a knowledge repository to display this information to the user because we just don't trust it sufficiently there. And next slide. This eventually will hopefully take us to a world where everyone can share the sum of knowledge because everyone can contribute in their language to abstract Wikipedia and make the knowledge in abstract Wikipedia available in many more languages, therefore making it maybe a bit more believable that we can have Wikipedias which are comprehensive, current, and correct in more than 300 languages, and therefore have access for many, many more people out there. Thank you. Handing it back to Crystal.
Thank you, Danny. All right. Those were very informative presentations. I learned a lot, and I appreciate getting a window into what you all have been working on lately. So we are going to pivot to our planned questions. The first one is, what possibilities for using machine learning or AI in your metadata work are inspiring to you? You can feel free to unmute.
I am really inspired to think about how we could possibly use AI to solve problems or things that are like things we do today that I really think AI can be a much more elegant and solution for and make there be less work. So one that I sort of have a vision about, for example, is if you think about language of cataloging and traditional bibliographic description, a lot of this is about, I want my notes to be in my language, which of course, is wonderful. It could also be that a user of your catalog wants yet a different language. So it seems to me that we can really use AI to solve this problem, not only because AI can be helpful at translation, but we also we have a lot of depth of knowledge, I think, about sort of library domain specific preferred translation. So this is just a way to think about the metadata becoming data that we can empower to do things and present in a different way than being like constrained by some of the things that we do now. And that's just like an example.
One place that I find particularly interesting with LLMs is, and this is something that Philippe has also pointed to, is that we can use it to translate natural language requests or queries or statements into formal representations, which can then be checked. And those formal representations then can be much more complex than what we are used to before. So I think actually that the previously formal languages, programming languages, as well as knowledge representation languages, have been limited by the fact that they need to be used by humans in the end, to be written by humans. With LLMs, we might push those limits out. We might make them more complex than previously, and have them also be explained by LLMs, for example, when they're being used or edited, so that we can have a much more fine-grained, a much more complex representation language for knowledge than we ever had in the history of humanity. And I think this is a very interesting point, and we are probably going to use it and exploit this ability of LLMs inside of Abstract Wikipedia by having more complex representations for knowledge than what Wikidata can support.
Thank you. Charlene, did you unmute earlier too?
Thank you for catching that. So at NYU, it's quite amazing to see the humanity professor or scholar very interested in using AI, natural language processing. So for their for their research project, especially about languages. So this is the area also my team with different kind of language expertise. We are particularly interested in how you use AI to for translation, transliteration, as well for especially for non-Latin scripts, because they were much more complex. We also use, AI to like do batch processing or remediation for example, one of our geospatial data, metadata remediation. It's just quite amazing how they use that, AI tool to really batch processing or fixing more than 4,000 records. And so with that kind of power, it's really, really helpful. On the other hand, as I mentioned earlier, working with computer science or data science student doing this kind of project, how to improve, because it's like the young student, they really care about the search platform is semantic search option there. So I think that's also have a lot of potentials.
Thank you. Any other thoughts on this question before we move on?
Oh, well, I could just, sorry.
No, please go ahead. Go ahead.
Okay, thanks. Yeah, so I think, what Charlene already mentioned is like enhancing or doing batch processing. I think especially like there are a lot of older records that are maybe not so detailed and or do not follow like today's conventions and practices. So enhancing these is one thing that is I think helpful for improving discovery across the different layers of the bibliographic databases, and also like doing more detailed cataloging or subject indexing on materials that were previously off limits because it would have taken just so much manual work to go through them all. So just to have more coverage in your databases thanks to being able to automate some processes with machine learning or AI or just traditional code, whatever, but having different tools available to do this. I think that's something that inspires me.
I find I have a lot of similarities to the other speakers and how it how AI basically inspires us. I personally, the way I see AI and machine learning tools is basically they're tools that let us do things in a more efficient way, but with maybe compromising on a margin of error. But that being said, it could be very helpful in cases where we want to access information in a more efficient way, some type of research or exploration, exploring like vast, very large amounts of data that personally as humans, like we are not capable of doing. And knowing that there's maybe this margin of error, like with accessing data, we are able to compromise on that. And I find, for example, the comparison of different languages, that's something very interesting.
Thank you. That is inspirational. The second question about practical examples, I think you all covered very well in your presentations. So if it's okay, I'm going to skip that one and address this third question of what limitations do you see with AI and machine learning in your work that many people do not yet understand? And how are information professionals identifying and communicating these limitations to stakeholders?
For me,
Maybe I could start. Oh, yeah.
Go ahead, Philip.
Oh, okay. Yeah, so I mean, basically what I've seen with the work that I've been doing with the MCPs, for example, I realized that there's a lot of cases where, I mean, okay, maybe we all acknowledge that there are some mistakes in AI, but in some cases, there's this limitation of AI not being able to say, I don't know, or I don't have access to that information. When I'm using the MCP with Wikidata and trying to provide LLMs access to Wikidata, sometimes it fails at finding the information, and in a lot of cases, it just assumes what the answer is and assumes the content of Wikidata. And I would think that this could be the case for a lot of cases where we provide LLMs access to external databases. I think this is like a huge limitation, but there are ways to avoid it, of course. Maybe asking the LLMs for references, providing resources to be able to verify the answers yourself. Yeah.
Danny, you had unmuted as well.
It's very similar to what Philippe has said. I think the biggest issue with the public perception of LLMs is that they are regarded as a knowledge store, and that we are switching more and more using traditional knowledge stores like libraries, like the good old web, like Wikipedia, to just getting answers from LLMs. And whereas there are places where LLMs are wonderful tools, they're just not very reliable for a lot of knowledge queries. And so that's one problem. And the other problem is that no one, not even the experts in the field, really understand the capabilities of LLMs and where the limitations are. We have no way of predicting when a new model comes out, like what will it be actually able to do? What won't it be able to do? And it's just like basically in the field of alchemy, we were just trying out stuff and figuring out, maybe this will work. Maybe the next model will suddenly speak 7,000 languages and all the problems are solved. Who knows? We don't. And no one can predict those things. And which also means that I have no way of explaining to anyone actually, like what those things are good for and what they're not good for. We get more and more experience in some areas where we can start to rely. Okay, it seems to be good at this thing, but really why it works or what it doesn't, we're far away from understanding any of those.
Can I go next? I liked very much the points by Philip and Denny. I just want to add one more, which is maybe a bit more niche. It was already mentioned before, but this limitation of the context window of an LLM, I think that's, I mean, um, it has it's not as bad as it used to be. With current models, they can take in quite a lot of information, but still it's a severe limitation, and most people don't seem to understand it. And they expect that if they point ChatGPT or Gemini or Claude to a website and say, for example, classify my document according to this list that's there, and it's a big vocabulary, and they expect it to read that and use it, but that's not possible because you can't cram a long text into that, or even if you could, that maybe the framework doesn't do it anyway. It will just summarize it into the prompt or whatever. Also, another thing related to this is that the framework around the model matters a lot. It's not just which model you have, but how it's sort of uh, hooked up to all the other systems, to external data, how what kind of prompting is used within the tool. So you can the same model can write excellent Python code when it's in one framework and then totally fail when you put it in another framework because it's just it doesn't fit the requirements, and that's something that I don't think many people understand, that it's not just the model but everything around it that matters. Thanks.
Thank you. Jeremy, you're unmuted.
Yeah. I think a limitation of understanding of AI, part of it is just the velocity of change with LLMs, the new capacity, new models, but new ways of using those models. It was already, other people have already mentioned this. Osama, I think you're absolutely right that we don't have what tooling you sort of surround your LLM. Oftentimes, you may not even be giving a text prompt, but behind the scenes, you may be using a generative AI model. I like to think of LLMs as providing a narrative interface to library systems. And before, either originally from the command line, moving from GUIs where you're pointing, clicking, and now we have a whole different modality, I think. And how do we communicate now? It offers up, I think, some great opportunities, but understanding those differences as a limitation.
Thank you. Does anyone else have thoughts on limitations and limitations on understanding? Charlene.
Yes. I think I already mentioned in my report is I also glad to see Asma mention about small language model is one major pushback from our community or faculty is really they feel a larger language model is black box. It's just unclear. So that's exactly why I mentioned earlier is sometimes the result is just very disappointing, very confusing. And on the other hand, some of our scholar faculty really care about the quality. They want to make sure, it's okay to be small, but it has to be correct. So I think this is the key issue. I think how can we maintain that quality? So we should be in that process, and rather than just use LLM without really knowing what's going on. So the other thing is sometimes the data could be outdated, could be offensive term, or could be something incorrect. So that's why I think that's the major limitation.
Thank you, Charlene. We've heard similar things at the University of Washington. I think from the iSchool community is an emphasis of quality over quantity is sometimes best. Any more thoughts on this before we move on to the next question? Right. What ethical safeguards have you seen put in place to address potential issues with data quality, environmental concerns, privacy concerns, or other potential drawbacks to these technologies? And do you think that they are sufficient? This is a tough question.
Yes, I guess I can take the first attempt at this one. I see there's some discussion along these lines in the chat window as well. And so when I was thinking about this question, when you gave it to us to think about in advance, I think the answer is no, they're not sufficient. And also the ones that there are not the because this field is changing so rapidly, there has not yet been the time for the deep thinking or for rules and policies that follow, but other things have been put into place that have been left behind, but are creating kind of structures that aren't necessarily the best ones either. So practically, I was just thinking about this in terms of, several times a week, perhaps I have to fill out a form explaining basically that we aren't using a generative AI tool in the way that the form is designed because they have fallen so behind where current technology is. So people understandably want to be careful and purposeful. There are really profound implications for deploying AI into our daily work lives and personal lives, along with great potential advantages. And because of the rapid pace of change, I think there hasn't been, we have not yet found ways to think about the correct balance of any safeguards or other considerations that we need to put around this. I think mostly for privacy concerns, that's actually where because of sort of our longer onboarding period to our previous technical environment, I think we can extrapolate that more, but more like other issues are kind of newer with AI. Environmental concerns is one that people raise often, and it's certainly valid, especially I live in a physical location where data centers just spring up like mushrooms overnight, these giant buildings. So thinking about how that works, but also not keeping that framed in a balance of like understanding maybe what you're doing. If it doesn't make sense to overscale computing for environmental reasons. It doesn't make sense for lots of other reasons as well. So that's why it's important to be extremely thoughtful in design of all systems. So that was kind of vague, but to say like, yes, we're figuring it out. So we as societies, right?
Yeah.
I see one question, if we can take it from the chat,
Of course.
where Amy Watson is asking, is it ethical to incorporate these technologies at scale if these ethical issues have not been sufficiently addressed? The word sufficiently is doing a lot of work in the sentence, obviously. But on the counter side, we also should be asking, for example, if given that these technologies do also have the potential to do a lot of good, would it be ethical to withhold them from the world? Shouldn't we be using these technologies if they're doing a lot of good? There are areas, I think, where LLMs can be used with great benefit and little drawback. There are areas where this is not necessarily the case. The chat interfaces, for example, seem to be leading to actually triggering mental issues in people, which is something that I would really think we should be considering more before we release such a technology. On the other side, there might be helping to literally save lives by giving more information and making more information accessible to people when they really need it. So I think this is like with all technologies. It's not good or bad or evil and good or whatever. We have to make a very careful decisions around it, and everyone will do it differently, obviously. But I don't think that. I just think it's very complex, and I agree with the question a lot.
Thank you, Denny. I think that's an interesting point about, the technology itself isn't necessarily the thing that is causing all these problems. It's sort of how we're wielding it, and the decisions that we make around implementation, rather. Any more thoughts on this question before we ask our final planned question?
Maybe one thought from my side. Because we're talking about there's a lot of concerns with large language models, and I mean the current state of AI and what it looks like. And AI has been around for a really long time, but currently it's being overblown in a way. And you've mentioned data quality, environmental concerns, privacy concerns. All of those are really important. Maybe one additional concern that I have in mind, the way I see AI and large language models, in a way, they kind of average the knowledge that is available in their training data. So with that average, they're losing a lot of nuances, a lot of perspectives that are basically underrepresented in the training data. So there is this concern as well that if we continue with this and we continue to add more and more generated data on the internet, we're more and more losing these underrepresented perspectives. So there is this additional concern that I like to mention as well. And maybe from Wikidata and the way we create the tools, we try to create tools, the AI tools that are more towards the accessibility perspective, using LLMs and AI to access Wikidata rather than writing data.
Thank you. All right, last call on this question. Okay. Finally, before we opened it up for questions from the audience, we've got several students in our audience today and sort of emerging professionals. And from your perspectives, what is the most important thing new metadata professionals need to know about machine learning and AI and metadata work? And where can they learn more about that? Yeah, Jeremy.
I'm going to be selfish here, and I'm the co-chair of the AI for LAM Metadata Working Group, and we meet once a month. So I think that's an avenue that if people are interested in learning more, we would really encourage you to attend. We cover different aspects of AI and metadata work, sort of on an ongoing basis. And lately, we've been seeing how you could use Cloud Code and MCP to be able to generate reports and actually do metadata workflows. So I'll just say that's one avenue. We'll look for these professional groups, and the AI for LAM Metadata Working Group is one avenue.
Very cool. Is that a PCC working group, or what is the umbrella?
No, it's sort of an international group that was originally started by Stanford and the National Library of Norway. They do the Fantastic Future conferences, if you've heard of that. And they have a number of other working groups, but given that the metadata working group is focused on sort of the overlap of AI and metadata, I think people in this audience at least maybe be interested in it.
Great, thank you.
Crystal, since you mentioned about PCC, so I would like to promote the use of guiding principles in the final report of PCC AI test group. And they also, there's a best practice. There's a lot of resources there, 51 pages. So I think for new metadata professionals, I think how can we use AI with like a responsible AI principle? That's very important. So for example, at NYU, we do have Center for Responsible AI, which really want to make sure, how can we make a responsible AI synonymous with AI? And so I think this is a very important principle.
Thank you, Charlene.
So to the question, where can they learn more? We also provide the UNIF tutorial for those people who are interested in learning hands-on how to use the UNIF toolkit for training their own models and setting up subject indexing workflows. So that's resources on the web, exercises and videos, and we also do sessions once in a while. The next one is going to be at the Open Repositories virtual conference in the beginning of June. So I'll put the link in the chat in case somebody is interested. I'm not claiming that this is the whole story about AI and metadata, but it's a learning resource for a specific tool and aspect.
Thank you.
Covers also.
So I think I would, to build it just on that point, so to kind of get back to the first point, first part of the question, what's the most important thing? I think the most important thing is to just keep learning and have an open mind and to try to focus, thinking about anything that you might be learning in your high school education and early in your career is a balance between learning like a tool and learning the principles and practices that will keep you going for the into the future. So thinking not just like what are the specific functions I need to learn for this tool, but really think about, well, why am I doing this? What is the purpose of this tool? And how can that maybe turn into something different in the future? Like I've been thinking lately too, just even about like, what are the formats of library resources that we just haven't even thought of yet? And how would we go about describing those? And it's an intriguing question.
More thoughts on this question before we open it up to audience questions? Thank you so much for those resources and thoughts. All right. So I think we can answer questions from the chat. If you've got a question that has gone unanswered in the chat, it would be really helpful to pop it into the question and answer box, just so that questions can pop out at me. So Laura asked, how can we provide more fine-grained or expanded data for discovery, or beyond that, research on specific domains of knowledge using AI? Thinking about subject analysis going beyond 3 subject headings to many terms. Like a back of the book index, but what ideas do you have? I know we've talked about small language models.
I think one way is expanding semantic search across your different collections, maybe in particular special collections, which contains a library's more unique collections. That gives you a much more or a much richer search capability and clustering. So you're not sort of limited by the 3 subject headings, but you can do multidimensional clustering. So that's at least one way to do that, to sort of expand and create that fine-grained search for discovery.
Thank you. We could probably pop over to another couple of questions that I think get at the same idea. So Laura asks, how do we evaluate outputs from machine learning, RAG, and agentic AI? What techniques do we need to learn? And then Amy asked in the chat that, the PCC task group final report is excellent, but doesn't provide much guidance on how to balance benefits and risks impacts. So how do we make those decisions given how difficult it is to quantify risks and impacts versus benefits? So evaluation and also judgment calls. How should we make those?
Well, if I can say something about the evaluation side of things, at least we have been doing that quite a lot with subject indexing and UNIF and testing out various approaches. So that there's kind of at least two different perspectives. There's the quantitative approach of having like a gold standard data to compare the output of an AI tool against and see how close it gets to the manually produced or manually curated answer. And that's very useful if you building such a data set, like a gold standard data. It's very useful because then you can do these evaluations whenever you want, like again and again, or using different methods and compare. So it's a one-time investment, but that's pays off. And then the other way is qualitative. So you have an experts look at the data and rate, for example, the AI answers. That's more labor intensive, but it's a complementary perspective. And if we're talking about like important tools that are sort of making important decisions or producing important data, then I think it makes a lot of sense to invest into both kinds of evaluation, both the quantitative and the qualitative sides, and because then it helps you to put some numbers on and also identify particular issues where the systems go wrong. Not sure I know enough about saying risks versus benefits, because that's a whole another perspective again, but at least having numbers and being able to track them over time has been very useful for us.
Any other thoughts on evaluation or on weighing benefits and risks?
Can I respond to that briefly?
Yeah.
Okay, so first I want to say the test group only for 1 year, we cannot cover everything.
Yeah.
It's already 51 pages. On the other hand, I think this is part of the best practice, I think, in the project management. On the other hand, I think this is an excellent question. Feel free, if I can share with PCC Policy Committee, I think this is a great topic for the POCO to follow up. And it could be for the new group to work on this. So on the other hand, really, it depends. Each institution may have their standards. So I think this is a great question and comment.
Thank you, Charlene. And that is very important to point out that the PCC is currently putting together another task group on this. And it's an issue that we will continue to collectively grapple with. And questions like this are very welcome.
So I was thinking about the evaluation question because I agree with Osma that it has to be a combination of qualitative and quantitative. And just having a conversation with our data science team, they were a little bit disheartened to hear that there was not a objective answer to what the correct subject headings are. I was like, yes, you can ask three. If you ask 3 catalogers, you'll get at least 5 answers. So therefore, how do we assign? It is extremely difficult in that sense to assess quality and correctness. But I think I also have, I think we should be also thinking more about the whys as well, because many parts of current descriptive practices were built on systems that maybe we can compensate for some of those requirements with more with in fact the very tools that we're talking about deploying. So yes, but it's, to me, it's all about, you can definitely measure productivity measures, you can measure researcher success measures. So there are other approaches as well at getting at how successful some of these implementations might be.
Right, kind of scrolling through the chat. Does anyone else have thoughts on this last question? Kind of a two-parter, two questions. Right. Ooh.
I will just briefly say I've done some experiments where you play one model against another and try. So, for example, I've had like Claude generate a report, but then have OpenAI evaluate the results. And so, using AI to do the validation, that still doesn't remove the person, but it sort of helps, I think, make it a little bit more scalable for some of this evaluation work.
We've got one more question in the Q&A from Laura, and this is a question specifically for Philippe. How does the embedding used for Wikidata harmonize with the embeddings used by LLMs? And embedding it for processing inputs. I'm not sure I fully understand that question. Maybe Philippe does.
I'll try to answer the question. Maybe there's a follow-up. But yeah, the way it works is basically you have this LLM, which is a very specific LLM, which is an embedding model that transforms your data into a vector. You can consider the vector as like mapping, and the mapping is based on the meaning or the context behind the data. So when you're creating this vector database, you're creating that mapping of all your data based on that meaning. But when you're using that particular embedding model, or the LLM, only the embedding model makes these particular vectors. So the vectors are not understood by other embedding models. It's a mapping to, let's say, a multi-dimensional map that is only understood by that model. So the vector database is only used for natural language, still using this the same embedding model, and it takes the natural language query and outputs the data or the reference to the data. So it's difficult to use the embeddings in other LLMs for like an output or something like this. I hope this answers.
Thank you. I think that brings us to the end of our time. One of our faculty members, Itza Carbajal, is doing some research for SAA issues and advocacy on how the archival community is feeling about AI for a blog series. So if you follow this QR code, you can contribute to that if you are so inclined. And then thank you again to our amazing panelists for sharing your deep expertise with us today.